Hi, everybody. Welcome to a brand new episode of the Clear to Send podcast. I have a special guest here today who's going to talk about uh, doing designs and validation surveys. He's been on the show plenty of times. I think the longest standing guest on this podcast, and he is UC Kivanimi. How are you, UC?
Hey, hey, Rowell. Thanks for having me again. How you doing, man? You ready to look at some true three dimensionality and some site surveys, huh?
Yeah, I'm ready to, put on look at Wi-Fi from a new perspective, get to see how Wi-Fi looks like maybe from the at the floor for people who are taller than me, like we'll see how what that looks like.
Sounds good. And we could look at some different environments. You're very familiar with all of these, but warehousing, education,
Mhm.
stadiums, like look a little bit all of these and kind of discuss the special needs and quirks and features, and also how to rapidly design complex three-dimensional models
Mm.
and how to wow your customers also with amazing designs and reports and just in pre-sales as well.
Yeah, I think that's important to know. Like, if you're doing a design, why does 3D matter, right? Because if you've been in a warehouse, you've got pickers who are down below. They reach really low to reach the bottom shelf, but then you got pickers who are on forklifts, and then they go about 20 feet up. So how do you know Wi-Fi looks good from the bottom of that rack to the top of that rack? Or maybe you're in a lecture hall and you've got an elevation, right? So maybe it goes about 14 feet up. How do you know all the students in that in their seats have good Wi-Fi? So I think that's a good idea to explain like why 3D modeling is important. And for those of you who are listening to this podcast, there is a video aspect to this, and UC is going to show us what 3D modeling looks like. I don't think it'll do it any justice if you're just listening to the audio. It's kind of hard to listen for that 3D piece, but UC, yeah, go ahead, take it away.
Yeah, I mean, since you mentioned, and it's funny, like totally unscripted, but you mentioned the warehouse and kind of the racks and shelves and picking the robots picking pieces from whichever rack. So let's take a look at that first. Can you see my screen? I wonder.
Yep, I can see your screen.
Perfect. So here's our tool, right? And what I did is literally just dumped in a JPEG and then built the racks. Took me like 4 minutes or something. Kind of a few main walls and the racks for this smallish warehouse. And it seems like I put in some like private cellular access points, and it automatically kind of optimizes them on different channels. But Wi-Fi is similar, and we can take a dive into Wi-Fi later on as well. This guy has like a couple of switches, some security cameras connecting to the switches, and some displays, and then these private cellular Node Bs as well. But if we look at the 2D, it's quite amazing already that we can actually predict in 2D and see the signals flying through the shelves, and kind of seeing at the bottom you can see because this AP isn't very high. There's shadows behind the shelf, stuff like that. But how do we know, first of all, that we constructed the model properly, constructed the kind of building properly, and then how can we see better kind of how the signals behave? That's why we built the three dimensionality, and I think this is like pretty exclusive stuff you're seeing, in a sense that this doesn't even ship yet. We've added like a lot of look and feel improvements to the three dimensionality, things like that. So if this looks a little different and a little better than your production Hamina product for our customers, that's because we will be adding a couple of like three dimensionality look and feel additions to this soon as well. But if we look at it in 3D, it starts to make a lot more sense how kind of the signals behave and go over the shelves and stuff like that, right? So
Yeah.
it just looks a little bit different that way. And then when you mentioned kind of the floor level
Mhm.
versus ceiling level, let's take a look at that. So right now we're looking at zero point 0.6 meters, so 2 feet high from the ground, which might be
Yeah.
fairly typical, height for a client. That's where the heat map sits. So that's where we assume the client device to be at.
Okay.
Now it's at 0 meters, so it's at the very bottom. And then as we
Yeah.
start raising it, I don't know how quickly this updates to you, Rowell,
It's
but
it's it's almost like it's in real time. Although I mainly operate in feet. I think 6 meters is what, 20
yeah,
feet,
yeah, yeah.
25 feet,
Let's
30.
for sure. Let's change that for you
That's
right
all right.
there.
Well, actually, while you change that, I just want to explain to people who are on the audio, like you've got a little knob here that you can say at what height a client will be at. And when and all you're doing is sliding, it's a slider. So you're sliding that over and it's telling you how high the client will be in meters or in feet, whichever your preference is. That way you can verify that you've got Wi-Fi signal at the height you need it at, where the clients will be.
Exactly right. Exactly right. So this gives another whole different kind of perspective. Uh, a few things like validating the project so that the shelves height. For example, here we have shelves and boxes of different height. Validating that all of that got done. The walls are of certain height and of appropriate height. Maybe you have some walls hanging from the ceiling, stuff like that. But also, when showing this to the customer in the pre-sales phase, or when you're constructing a report for the customer, it's a different animal. And actually, you can see here if you look closely, there's even there's a ramp there and a raised floor. So that
Oh,
kind of
okay.
leads us to a whole different dimension of three-dimensionality where you can raise floors, do ramps, things like
Yeah.
that, and
So
not
I'm
just.
curious, could you create a mezzanine then? Because I know mezzanines are somewhat popular with a few warehouses and
So yeah, you could raise the floor up, or you could create just a slab
mm,
as well, and things like that. So
okay.
absolutely, absolutely. Uh, and
Yeah, and
if
I like how you're explaining how you can show this to people because I think this is where it really starts to click with project managers and cable installers. Like sometimes you don't want to have those APs installed right over the rack. So it's really easy for them to see, all right, well, I've got my product there. What does Wi-Fi look like in the aisle? So I think that's a really
exactly right,
great way to
exactly.
collaborate with others who are not Wi-Fi professionals.
Absolutely, absolutely. And then, if you use the slopes a bit more extensively, you can actually work your way through stadium design as well. For example, here this stadium consists of I don't know 25, 30 slopes that kind of curve around the stadium. And then you can even do quirks like, I don't know, that little, what is that called, where the guys coming to the stadium from, like the
Oh, the
entrance to the
tunnel?
stadium.
Yeah.
Uh, so yeah, actually, some guys when I was showing the product to somebody when the 3D had just came out, and they were like, "But yeah, you didn't model the place, the entrance where people coming from," and then live, I kind of modified the slopes and put that there. So essentially, like I think the beauty is kind of keeping things simple, but still allowing people to do super complex designs if necessary. For example, see here. Here we have just a a raised floor and then a slope to the raised floor, right? And that's an oversimplified example of how to construct these things. You can see this ramp, right,
Yeah, it's funny
leading to
on
the
the
raised
right on the
floor.
football field.
Exactly. Beyonce is about to perform or something like that. So we actually do the work in 2 dimensions, and then we just
Mhm.
flip it to 3D for analysis and for validation stuff like that. Let's create another one of those. We all probably know how to do walls and attenuating objects, but what if we want to do those raised and raises and slopes and stuff like that? We just put in the height of the, let's say for a raised floor, height of it, and also of course what's important is the material of the raised floor,
Mhm.
since the signals will also go through that. So let's put in I don't know, a 5 feet thing there, and we could modify it after the fact. We'll just enable the raised floors here. So let's say it's exactly 5 feet. And there we go. So we can see, yeah, that's
Yeah, so
that's the
switch
one
to
there.
3D. So you're building the raised floor slopes in the 2D model, then flipping it over the 3D to view it.
Exactly. So you get kind of the ease of use and quickness of deploying these things, but you combine that with true three dimensionality. At least that was kind of the founding idea here.
Yeah.
You decide, how we succeeded. But here we could, for example, say lower height of the slope is 0 and upper height is 5. So from ground to 5 feet,
Mm.
and we'll keep that. Oh, we need to reverse that. There we go. See orange
Okay,
and
easy
black.
reverse. All right. Yeah.
Yep. And then as we so there we go. And kind of the stadium is made out of similar slopes, right? So
Hmm.
so here's a slope. You can see the black dots form a line, orange dots form a line, and the next slope would be here. For example, this would be one more slope, stuff like that.
Okay.
So the stadium just consists of slopes, and then of course here we kind of cut the slope
Yeah.
so that
Yeah,
it
because you got a
starts at
tunnel right there. It doesn't go all the way down like the other slope.
exactly
So
right,
it's
exactly
pretty
right, and then
easy to map it closely to how the stadium looks like.
exactly right, exactly right. And then you can get a pretty good overview of it. And what you can do with the slopes, because often slopes are used for stadiums and arenas and stuff like that. We actually added a feature where you can directly add crowd on top of the slopes, because often you
Okay.
want to model the audience sitting on the slopes, because that will affect the signal, especially in
Yeah.
underseat type of deployment
Yeah.
where you
Under
actually utilize
seat
the
or
crowd
even
to
on
your
the
benefit.
railing. You want to see how far that signal can get to through the attenuation of the crowd. Okay.
Exactly right. Exactly right. And for example, if let's put a floor mount Cisco 9166 here, and we look at, let's say, 5 gigahertz Wi-Fi. There we can see that it actually quite nicely is contained until, because it flies over the crowd, it actually does hit these opposing stadiums. Because it kind of flies, there's not so much crowd in front of the AP there compared
Okay.
to downwards,
Yeah.
but
So
that's
you can
that's also because
predict.
of our threshold stuff like that. But
You're
that's
predicting the signal of that AP even on the other side of the stadium, like how far that
even
signal
on the
would
other
go.
side of the stadium. And there's a lot of like stadium deployment persons, like Chuck Lukaszewski has spoken about this very thing,
Yeah.
where from the very other end of the stadium you can hear an
Hmm.
AP and get actually decent throughput
Yeah.
on a phone from the other end of the stadium. It's just the thing that happens even if you do underseat APs. But if you do an underseat, it's quite well actually contained, because I have modeled some crowd on top of this. But if we move this
Okay.
guy to
Yeah,
the
you can
actual
see the
stadium, see
propagation
what
changing.
happens. It's very well audible everywhere.
Yeah.
And
Yeah.
again, so
So that
that's
crowd attenuation is actually working.
exactly. And of course, we could also start to see like interference problems. Let's look at like let's make this a chaotic scenario where we're enabling everything on 2.4. So we'll enable auto channeling, but we will enable all the 2.4 radios. And when we start kind of building this out, of course, like if we didn't disable any of the 2.4 radios, no matter how badly the software tries to optimize the channels, the 2.4 will pretty quickly turn pretty chaotic.
Yeah.
Of course, that's just that's just the nature of the beast.
Yeah. So
But
quickly, easy to deploy and easy to look, or easy to design and easy to see. All right, I have an issue here. I need to change frequencies. There's not enough 2.4 available.
exactly right.
Even if someone were to say, well, maybe the crowd attenuation might help, it's not
Yeah,
helping
it's
very
not the
much.
ultimate solution, right? But crowd attenuation does help. If we have everything at 0 feet, it does
Mm,
help dramatically. But if we raise these, let's say at 6 feet, if we have those on poles, see what
hmm.
happens with the interference.
Yeah, there you go.
So dramatic difference on the crowd attenuation, just absolutely massive. So we can see on the bottom left, we can see how many APs are interfering,
Yeah, quite a
even though
lot.
we
Yeah.
not nearly filled the stadium with APs. It's pretty bad. So
Hmm.
coverage is easy on the stadium. the hard part is eliminating the interference. Of course, if we disable selectively the two floors, then we'll start to get a better result. But then we'll end up disabling quite a few of those as well.
Okay. Oh,
That's
that's good. I like the whole crowd attenuation, the sloped floors, the raised floors. Really cool, useful features for designing a complex environment. And for me, it's more in higher ed use cases where you've got the sloped seating where it's a lecture hall. So I can see this working pretty nicely.
exactly. But we could look at a quick university design and then see if we can flip that into get any 3D benefits out of that. So you're fairly familiar with university, aren't you, Rowell?
Yeah, yeah,
You've served your time, one could say, right?
yeah. Done some pretty large lecture halls, and usually capacity is an issue with the installation options as well. And I think when working with installers, they always want to install it hidden, tucked away in the walls and the ceiling. Some of them don't want to do underfloor because of the construction costs, but this is a great way to show them, like, hey, here, let me design it your way and show you what Wi-Fi looks like.
Mm-hmm.
And they tend to agree with you afterwards when you create a design, because you just get all the stakeholders involved. You have the construction, the architects, you've got the IT people for that specific school. And
Yeah,
when I'm showing them, like, hey, here's what happens when you do a bad installation, they tend to listen. And I've done it with Hamina, where they did a lecture hall and they
yeah.
wanted to tuck it away in the walls hidden. And I showed them what would happen if somebody walked in, and it showed that they only stuck to one AP, even though there was three APs in the room. And so we went from mounting them on the wall to mounting them on the ceiling,
Sweet.
and not unhiding the APs as well. So they, once I showed them that with Hamina, they agreed.
So they bought the idea, huh?
They did, yeah.
Nice, nice, nicely done. And what I'm doing here is I'm just let's say maybe this is an educational space and see how the now the stairs are lined up. I'm just building something that we can use to test against. I have no idea how these guys line up, so I'm gonna maybe that's a different building even. But we'll use two floors, line up the stairs, and maybe for the second floor as well, we'll bring in some walls and stuff. Just give me a sec here.
So
So that's automatically
you're
scaled since we
building this out pretty quickly.
well, yeah. I've used the software, once or twice. You could say so.
Well, in the matter of the few minutes I was talking, you built out two floors with the walls, align
and
them.
multi-floor, right?
Yeah.
Uh, we know here's a courtyard here, so we might want to use like a floor hole on the courtyard to freely pass the signals through as well. So there we go. And there you can see kind of the walls that were derived from the automatic wall drawing system. And same with floor number 1, looking decent. We'll take out the walls and we'll start. What's your AP of choice these days, Rowell? What do you deploy the most?
Using the Mist AP45.
So that would be Juniper AP45. That's a Wi-Fi 6E, 6 gigahertz capable, AP. So let's start deploying. But before that, channel width. What's your favorite channel width? Like, how do you like to configure? Like, what's the assumption on a carpeted space for channel width?
Yeah, for 2.4, it's just the 20 megahertz. For 5, I still use 20. And then for 6 gigahertz, I'll do 40 or even 80.
Excellent. And on 6 gigahertz, you guys have all the luxury in the world, right? You have all that 1200 megahertz. But so what we implemented actually is this automatic, channel width selector. So it looks at every time you see how Hamina, every time it calculates the channels and kind of like optimizes channels every time you make a change. Now it also, like, every time you make a change to your network configuration, add an AP, move an AP, whatever you do, it also looks at CCI and can I handle this channel width, or could I go higher or could I go lower? Let's look at that in action. so it says, okay, I actually automatically start to work on the channel widths, and I will look at, there's no interference obviously, so we'll look at primary coverage to begin with,
Yeah.
and
And it's
kind of start.
calculating this on all three bands as you
All
place these APs.
except, well, 2.4 we don't need that, right? But now
Yeah.
it, for example, like you said, 80 on 5 might be a good idea, but since we are doing a pretty dense deployment,
Yeah.
it
It
actually fell
automatically, it
down.
started it off at 80 megahertz wide at 5 gigahertz as you place the first few APs. And now
Exactly.
that you're over 6 APs, it said, I'm not using 80, I'm using 40 megahertz now for 5 gigahertz.
Exactly, and now it went also to 80 on 6, because the APs are
Okay.
close enough to one another to interfere with one another. That's kind of the thing. If we made a sparser deployment, then no problem there. And now it says I also dropped 6 gigahertz to 40
Oh, wow. Okay.
at this point. So that's kind of how that goes. And
That's really
let's
cool. I
maybe.
like how you're able to just automatically do that without me having to go, all right, redo all these APs in a new channel with.
Yeah, exactly right. And there we can see kind of the end result, and we should not see a lot of interference here. It's clean on 5, it's clean on 6.
Mm,
So
okay.
our automatic channel with optimizer is pretty aggressive. It's pretty picky. It's very like Finnish, or
Yeah.
so it has to be perfect. Like otherwise it will drop the channel width. We will
So
be
does
bringing
that
like a
mean
little bit of a
the
slider options
threshold?
there to.
I'm just curious, like your thresholds then for changing the channel width, is that set on Hamina? Is that something that's user
It's right now
configurable?
it's a black box. So even if it gets like a fairly significant amount of interference, even just two APs
Yeah, it'll
colliding
change.
with or CCIing each other, it will down tune. But
Okay.
what we've
Okay.
thought about is like, clearly sometimes that doesn't yield maximum performance.
Mhm.
So it yields excellent performance and very low latency every time. But if you want to go for, let's say, sacrifice latency a little bit,
Mhm.
every packet doesn't go through, but you want to maximize perhaps the aggregate throughput, then you might want to use actually wider channels and still tolerate a little bit of interference. So that's the kind of knobs we will be bringing.
Okay.
And yeah, let's look at floor number 2. If we look at interference, of course, it's clean. If we look at coverage, you can see that, it's blasting on 2.4 as well as 5. It's blasting through the hole, of course, but if
I
you look
see.
at
Yeah.
individual APs outside of the hole, it's fine. But,
Yeah.
that's what happens, right? We all see that in courtyards, and you go here, a massive number of APs
Yeah.
audible
So
in this
you're on
area.
another floor now, and these icons that look like the APs, that's actually an indicator that there's an AP on the floor below, indicated
Exactly
with the
right.
arrow, and it looks like it's going downstairs. So that's how you
Exactly.
know it's
Exactly.
an AP down below. Okay.
Yes, sir. Yes, sir. That's exactly right. And now we could start also building up the network. Maybe we would actually prefer a little bit more of a corner placement here. If you're okay tolerating like APs associating, at times to the floor above, floor below type of APs. So
Yeah.
that's so that's what we get. And then you might ask, okay, how do I need some kind of CAD stuff to convert this into 3D? No, it's just you may have used this in your pre-sales work, Rowell, as well,
Yeah.
and as well as like customer reports and
Hmm.
stuff like that. But yeah, you just flip it over, because we already we
You built
took
the
in the
walls.
PDF.
Yeah.
We clicked on the wall, so this kind of comes free of charge. And if you want to do more magic to it, change wall materials, things like that, that's of course
Yeah.
doable. But
Yeah, I
so
have used it in a pre-sales mode where someone looked at the floor plan and said, "Hey, I'm concerned that signal doesn't get into this room," even though they saw it in the 2D model. So I
mhm,
converted it to 3D, and I said, "Look, I do have the wall outlined here. There's an AP
exactly.
on this side. The signal is predicted to go into that room, negative 60 dBm," and they're like, "Oh, okay," and then they went on with the installation.
Exactly right. Exactly right. And you might say, I didn't, for example, the staircases with the from the PDF they were not a separate layer, so I'm just gonna flip them into concrete, and now you can say it's much thicker, the material. This is the kind of stuff
Yeah.
I also like to use with customers, like see how thick the walls are and things of that nature.
Okay.
Yeah. Um, so that's that. So should we look at now that we've done the design, let's
Yeah.
say, what happens after?
Yeah.
I mean,
So we did the design, they did the install, and we need to validate it now. So does Hamina
exactly.
allow you to validate the Wi-Fi network as well?
I'm glad you asked. Nowadays, we actually do. So we built an app for the iPhone, for the iPad, and for the MacBooks to allow for exactly that. We also built hardware for that too. So this little box which
Okay.
has four Wi-Fi adapters, Wi-Fi 6E, and then the app
You just use
hosts
your
everything like the
iPhone,
maps, things like that.
or you just use a mobile device to do the validation server with that piece of hardware.
Correct,
Okay.
correct. And the mobile device can be an iPhone, it can be an iPad, it can be a MacBook, even as long as you have the Apple series MacBooks. And then
Okay.
for analysis, you can use the mobile app. And then for more comprehensive, bigger screen analysis, you can revert back to the planning tool to do that as well, if that makes sense.
Okay. And all that data collection from this device, does that get stored on the mobile phone or iPad and then it gets sent to the cloud? How does that work?
Yeah. It's first stored in the iPad or in the phone, and then
Hmm.
when it has a chance, it will push that to the cloud. So it works completely independently, in a way of the cloud. Let's say
Okay.
you're surveying nuclear power plant or a mine where there's no internet access, and then when you come back to the ground level, that's when you get some
Okay.
breathe some fresh air, and the tool will automatically sync back to the
Okay, that's
cloud.
good. Yeah, because I do come into a lot of scenarios where we're just not given Wi-Fi, or whatever Wi-Fi we're on doesn't have
Yeah.
access to whatever we need to send this out to the cloud, or it's slow because they throttle it. You name it. And this device,
Yes.
of you guys built this device?
This is made by our partner Asium, who
Okay.
make wireless, hardware instruments like spectrum analyzers and oscilloscopes and things like that. I think that's where the name comes from as well. Uh, so it hosts four 6 GHz capable high-end Wi-Fi radios, as well as battery. It has a USB-C connector for data, but also another USB-C connector for simultaneous charge if you so desire.
Oh, okay.
A USB-A port for spectrum analyzer, which there's a like a host, or that there's a strap that comes with the main unit, and you can optionally put in a small spectrum analyzer in the strap or not. So
Okay.
spectrum analysis is optional based
Got
on
it.
customer feedback. That's what people seem to want.
Awesome. Yeah, I like the small form factor as well.
It is very small, and it is very light, so you don't need to think whether I will take this on this trip or not. It's always kind of like, at least for my laptop bag, I always put it there
Yeah.
whether I know I need it or not, and it comes with a pretty handy carrying case that
Yeah.
fits the unit and the USB-C cable
Yeah,
as well.
that's perfect if you're traveling, because I traveled recently and TSA looked at my other device and I was like, yeah, I come through here regularly. And they were wondering what it was. But I like
I
the
know, I
smaller
know.
form factor just for that reason.
Exactly, and the battery is no issue because it's so small. Even in the TSA, it doesn't matter.
And with the small size and the battery, how long would someone expect to perform a validation survey before charging?
Easily half a day, and then
Okay.
you would charge over lunch hour, and then you
Yeah.
would carry through the rest of the day.
Yeah.
That's
But
kind
you
of
did
thing.
say there's another USB port so you can
There
simultaneously
is.
charge it while you're
Yep,
validating.
yep. That's what we're. Yep.
That's awesome. Okay, that's something that I wish I had with other devices, because on the larger validation surveys, you would have to stop and charge. And so now I have this really big Anchor battery that can
Mhm.
charge devices very quickly, but then it also
Yep.
drains that
Yep.
battery quickly as well. But it gets you there. But then that means carrying another battery, right? Another big, heavy unit in your backpack.
That's right. That's right. And here we can kind of see well, just take, where in we can see, for example, how the guest network is doing, the primary signal strength, the secondary from that network, and then the loudest neighbor, which is actually this time you can see the red line. It's
Yeah.
actually louder than the
Then your primary.
than your primary. So,
Yeah.
there's definitely some, well, surprise, surprise, that in our
And
office there's some neighbor issues.
so how does it
I have
know
no
it's
idea
a
where that could be coming from.
yeah, it could be one of those few APs behind you.
Maybe. And you
you're,
can
you're
see how I
you're
turned and
blasting
how
so
it
much
affected the
Wi-Fi there.
signal. As well as I, move here, it of course affects the signal.
Yeah, yeah, I
Uh,
see that. Okay. And but
and
how
then
does
you
it
have
know that it's a neighbor AP?
Based on the SSID, so at the top right, that's a
Okay.
good question. At the top right, you can see guest of Professor Frink. So that's the SSID that we consider our
Gotcha.
production SSID, and also all the other SSIDs from that physical AP are considered to be okay, but the
Mhm.
neighbors are some other APs. Okay,
Got it. Okay.
so we do a little bit of MAC addressing magic there, not real magic. And then you can see pretty quickly how your channels are distributed. If some channels are oversaturated, some channels are undersaturated, stuff like that. And then there's the use, we actually separate this into two easy to use tabs. We hope easy to use. Like, here's all the SSIDs for you, and
Yeah.
here's all the APs for you as well. So
Okay,
that's
so you can easily see and that's all on
yeah,
one page. You just scroll down to see everything. And it's
exactly.
more of the, I guess, analysis of uh, the network that you're looking at. But if you're just needing to get that quick glance and do the validation survey, the very top portion of this page gets you what you need as you're doing
Yeah,
the validation survey.
exactly right. Exactly right. See kind of your, primary and secondary, see the channel distribution, and then if you need, see what SSIDs are out there, what APs are out there. So
Very cool. And then along the top, you still have other tabs to go between the different bands. So you can see 2.4,
exactly
5,
right.
and 6
Exactly
gigahertz.
right. Like, for example, 6 is pretty quiet here.
Yeah.
So
Just a neighbor on 6 gigahertz.
there is a neighbor on 6 gigahertz. Exactly right. Exactly
So,
right.
so
So
you switch between two windows there. Um,
yes,
one
sir.
showed kind of like the networks with, and then you scroll down. Like, what's this one compared to the other one? Because
Good
now it just
question.
says
This is kind of
scanning
the
5
starting screen, if you will.
starting.
So,
Okay.
so here we just get a quick glance of the currently audible signals. It also tells you, the hardware device is present and it's connected. And
Okay.
then here's where you have all your projects. So if you want
Oh,
to
okay.
take a
Got
look
it.
at a specific project, no problem there. If if we just pick a project, and then we search for it, we click on it, because I
Mm.
have hundreds of projects, so probably better off searching it. And then we could look at, here's where I walked, here's where I took notes.
So you can
So
actually
there's an
view your validation survey afterwards and look at it on your mobile device.
Absolutely, absolutely. So
Okay.
now we're looking at kind of, yeah, exactly, afterwards, like once we have actually walked with the phone. So I meant a little bit vice versa. It seems like somebody left a note next to the elevator saying, "Not for Eddie F," whatever that means. Not sure. Yeah. So when you get this, you can either bring in kind of the project that you started. Let's say you did a design
Mhm.
on your cloud-based tool, and
Yeah.
then they all show up here,
Yeah.
and none of the predictive is there to disturb you. Like, we look at
Okay.
survey as a different
Yeah.
animal. So we just use the floor plans, the scale, and you're ready to go to survey if you've done the design. Or maybe you've
Yeah.
just put in the maps in the browser based tool, and then those are shown here. Or maybe you build the entire project using the mobile tool. So even if you have PDFs CAD files,
Yeah.
anything. You can slap them here, create a new project here, slap the floor plans here in, and in the mobile app, and
Yeah.
then you're ready to go. If that
So
makes sense.
so what you're saying is once I do the design, let's say I send somebody to do the validation, they can
Mhm.
open the same project that I use to create the predictive model,
Exactly right.
but you're not going to
Exactly
show
right.
them the predictive APs. You're not going to show them the walls. It's just the floor plan, and they can just start doing the survey.
Exactly. They're ready to go
Okay.
without distractions. And
And
then, yeah,
just
go
real
ahead.
quick before you move on to the type of survey, it I think licensing is a big thing because if I'm sending someone, how are they going to log into this app? And is a survey piece included with the predictive design? Like, are they separate,
Really
separate
good
products?
question. Really good question. Our planner is so inexpensive, starting at 390, so we couldn't include the survey in it. But the base survey package for to equip a surveyor starts at 2,490, and it includes the Nomad hardware, and it includes the app for a year, and the subsequent years for the app are 780. Now that's per user pricing, but you can of course, like if somebody leaves and somebody else replaces them, we can you can even, or like yourself, kind of reassign the license to the different person and stuff like that. But it's per user, the app, and then the units come with the app. You
Okay.
buy them as a bundle, 2,490 for the bundle. And
Okay.
if you want spectrum
Got
analysis,
it.
that's an extra 900.
Okay. Cool. So that way, this my guy who's doing the validation, he's got his own license just to do the validation surveys while I'm doing the designs, and I just send it his way. He's got the hardware, the app, and he runs with it.
Mm. Absolutely,
Okay.
absolutely. That's how you could run with it. And if your guy happened to be, if he's very very senior, he could use the continuous survey, obviously, with a little bit of point survey here and there. So point survey is the simplest one, right? You just
Okay.
click, you wait, and there you go. Continuous is continuously collecting data. And we also implemented line survey, which is
Okay.
kind of like, it tries to bring the speed of, almost the speed of continuous, but you get a little bit of relaxation and breathing room between the clicks and stuff like that.
Okay.
So whereas continuous survey, you have to be kind of alert all the time and click
Yeah.
really precisely. And with point survey, it's not collecting that much data over time. Line kind of tries to combine collecting a lot of data, but still relaxing between the lines.
Yeah.
So
So it's collecting data between the point you start the line survey and then when you end the line survey.
exactly,
And it
exactly,
won't collect data until you create another line survey.
exactly right. That's well
Okay.
said. So it
Okay.
gives you a little bit of breathing room. It means a few extra clicks if you compare that to a continuous survey, but it's a lot more relaxed way of doing surveys.
Yeah.
So kind of trying to.
And what would you say is the recommended way to do these surveys? Because the point one is, it sounds like to me, if I were going to go into this one specific room, I can't really walk in the room. Maybe I'll
Mhm.
do a point survey. Or if I
Absolutely.
need like an additional survey point, I'll do the point survey. And I just stand there, tap, wait for it to, I guess your device will scan all the frequencies and then collect those data points.
Exactly right. Exactly right. Let me open. There's already survey data here, it seems, but that's fine. I'll just, yeah. So if it was a tight like a room or something where I needed to collect a little bit of data, let's say on the staircase, I would just click there,
Okay. Oh, I
and
see.
that
And
would
you
be
have
a
a little
point.
indicator of how long you have to wait until it stops collecting that data and you can move on.
Precisely, precisely. Let's take an airplane here. Let's see how that goes.
Oh, are you doing surveys while you're in flight, EC?
Of course not.
Like,
This
excuse
is
me,
actually, I was
pilots
trying
just
to,
need to survey the cockpit real quick.
I was trying out the three-dimensional modeling. So, and this also becomes almost like a coloring book where, you fill the area with surveys. So that
Yeah.
would be the point surveys. Then we could switch it to line, and we would click at the beginning, see how the dot appears, walk, to the right, click at the
Yeah.
end. And now you could relax, walk to the next aisle, click at the beginning of the aisle, walk to the left here on the map, towards the front of the plane where Rowell typically sits, and then click there. So
I
that's
wish.
the beauty of the line. But
Okay.
obviously, the beauty of the continuous is, just keep clicking
It
your
keeps
way through.
recording.
Yeah,
At what point would you actually tap on the screen to create those blue points there? Can I
that's a
just
really
keep
good
walking, or
question.
do I have to do you have to tap on it at a regular interval?
You would tap at it on a regular interval whenever you see a good landmark or whenever you kind of reach the end of the aisle, at least, and as frequently as you can see a reliable landmark or where you are. So for
Okay.
now, there's no like AR assist stuff like that, but that's definitely coming.
Yeah.
I'm a big believer in Apple's room plan. You can see some of my posts on LinkedIn about
Yeah.
that too. But
But
yeah, that's
if you
definitely
were to
coming.
make a turn, you should tap on that to indicate that you're changing directions.
Precisely right. So
Okay.
whenever you turn, whenever you stop walking, and whenever you start walking, that's when you would click on the map,
Okay.
on the
And
continuous.
can you go into the data collection part? So like I see you're walking and then there's aisles. How far should those lines be between each other? Like until it has to do some sort of extrapolation to come up with, say, in between those two survey lines, it needs to predict some signal in there because you didn't exactly walk, say, in the seats where the people are
Mhm.
sitting there. So how would
Exactly.
it? What's that distance that you need to have between survey lines?
I think it's like we try to put a reasonable default on the extrapolation. It all comes down to the amount of extrapolation we do. So we try to put in a reasonable amount where we know that if it's a fairly free space, the RF doesn't change within a couple of meters too much. But if it's a sharp corner and you have thick shelves or thick walls around that corner, then certainly you want to click, as frequently as you can. So I think like as long as you click when you stop walking, start walking, or turn, and then whenever you see a good landmark, that's good. But your question is like like how close to one another should the paths be? And I
Yeah.
think in free space less, and in very very closed space with lots of like either clutter or walls or stuff like that, then it would need to be more. We try to put in a reasonable amount of again of
Okay.
extrapolation there, but you can go as detailed as you want
Yeah.
as well. But
Yeah.
I would
I
say
figure the
free
more you
space,
walk, the
not
more
much.
closer those lines are, the more accurate your validation survey will be. But you will have spent more time walking. And so in a lot of my cases, whenever I'm walking and there's a wall, I typically walk on both sides to
Yep.
show like what that attenuation would be of that wall.
Exactly. Preferably, that would be a good idea as well. That would be a good idea. So as much as you can afford, you should probably walk. That's how
Okay.
I would put it.
That's a good way to put it.
But yeah. So that's kind of that, and then we would get that same thing
Yeah.
on the planner as well. Let me just
Yeah.
check on
So
that.
once you stop, when does it upload that data to the cloud? Do you have to say,
It
hey,
already
upload
has.
now?
It already
It already
has.
it does it as long as there's an internet connection.
Exactly right.
Okay.
Exactly right.
Now, do you have to end your survey in order to upload, or does it upload as you stop actively doing the
That's a really
validation?
good question. Our app actually, even during continuous survey, it at least saves the measurements on the kind of the local storage here. So even if if a catastrophic failure happens in here, it still has like, and it's happened to me a lot. I forget to charge my batteries. I'm a sloppy guy. It's happened to me a lot during the stress testing. Sometimes intentionally, sometimes not. But what it does is it actually just misses a couple of the last continuous survey points. So
Mhm.
even if you do a 15-minute continuous survey,
Mhm.
like without stopping it ever once, for me it was just missing 2 or 3 points of
Mhm.
the entire survey. the last 2 or 3. So it's continuously saving to the disk. The guys made it pretty ingenious. So even if a failure happens,
Yeah.
that's, your data is still there.
And when you say points, are those the points that you tap, or the points the collection points it's collecting, that the device is collecting?
In continuous mode, it's continuously
Okay.
scanning and kind of interpolating also when you don't tap. Same with
Okay.
the line survey. It interpolates the readings all the time, even between the clicks. But in
Okay.
stop and go, it's pretty much only
Just
stored
that
data
one
where you're
point. Yeah.
at
Okay.
just at one point. Exactly right.
All right. So now you've opened up from your desktop the actual validation survey. So this is the at which point you would actually do your analysis of the validation with a bigger screen,
Precisely
obviously. I
right.
mean, you could look at it on your little phone if you wanted to, or maybe a tablet,
Mm.
but this would probably give us the best way to analyze everything.
Yeah, yeah, this is a little bit easier, and I mean you can analyze the different surveys. We can see here that I only did, I guess, continuous. You could click on the AP, see their coverage, stuff like that, and also see the AP properties, things of that nature, the
Okay.
SSID is
So you can see you're
everything.
you're viewing of an AP that got placed during the validation survey. You click on the individual AP, you can see what channel it's operating on, the channel width, the BSS IDs.
Exactly right.
Okay.
And you can also like put in the AP model number for, we can't detect the model number automatically, unfortunately, but you could put it here for documentation purposes. You could say, document its mounting type and stuff like
Okay.
that. And then you could of course add notes and things of that nature
Do
as
you do
well.
you auto detect what vendor it is?
Yes, we actually do. We actually
Okay.
do. And we kind of have to auto detect the vendor in order to understand like which Macs come from the same radio and stuff like
Got it.
that.
Okay.
It didn't seem to do that here, but then I surveyed this on a very much a prototype a month or two ago.
Okay. Very cool. And so here we can check the usual, right? Primary coverage, secondary coverage, channel interference.
Exactly. Yeah, the huge. If we want to look at secondary for secondary for this specific SSID, for this specific frequency,
Frequency.
or
Okay.
primary, or what have
Yeah.
you.
Now
So
this is
so
the data that's collected by the hardware. What if I'm using like a handheld scanner? I'm pretty sure the received signal is not going to be the same when you compare them. So is there a
oh
way
man,
for
I
me
wish
to
I got a
put in
dollar.
here?
I wish I got a dollar every time I hear that. So absolutely, what we do, so we factory tuned the devices down to like an iPhone-ish type of level, which is
Okay.
usually the kind of least capable, most common device that's very commonly used. If you need more strict, thresholds, there's a couple of ways you can do it. You could alter like a stricter baseline for your RSSI coverage here. There you go. You can see it shrinking. If I put it like overly dense, like 57, you can see it kind of shrink
It
the green
shrinks the
area.
coverage. Yeah.
Exactly. That's maybe the way I would probably do it myself.
Okay.
So I in at least in the beginning, and the offsetting kind of thing is a hot potato, but if you ask me personally, I'd like to stay out of it as much as possible just to avoid confusion in the industry. And it
Mm,
seems like there's a lot of different schools for this
yeah.
this thought. I would like to just the device to be pre-configured from the factory so that the default heat maps that you see represent the experience for most of the users on a fairly LCMI device. So that's kind of how I see it, like good defaults and then tuning them through the requirements here. You can put stricter threshold to kind of
Okay.
fine tune if you have an exotic barcode scanner that has a really terrible radio.
Yeah. So instead of doing an offset value here, you're just adjusting the Wi-Fi coverage parameters, and you tune to what your primary coverage would be, what you want,
That's
what you
Yeah,
want it
yeah,
to be.
we're still arm wrestling this internally and externally, like how it should be. But I think this is a good starting point, and we
Yeah,
are
yeah,
very happy to have this discussion with everybody in the industry as much as needed to kind of
yeah.
come to a conclusion that everybody's happy with.
I mean, from a holistically, like this will probably work for most environments.
Right.
I'm really speaking to very specific like warehouse, or there's some really special device. Maybe it's a automated type device that roams around on its own and it's got a very specific radio on it. Those are very corner cases, but for the most part this will probably work. And if we're talking like carpeted office space, it'll probably give you the results you're looking for.
Exactly right. Exactly right.
Okay, very cool. And so
Yeah.
let's say I need to give a client something. I know this is like very interactive for them to look at. And
Mhm.
what if they want something to keep for themselves? Like this is a point in time. Rowell did a survey for them or for us, and I need to show it to other like executives and say, look, we did this survey. This is what the partner said. How does that work with the validation service? Like there's a reporting feature to it.
Yeah, absolutely, absolutely. Kind of the same. I think we covered it last time, where or the time before. You have the two reporting options. You have the static, which I think works really well for the survey data. Like this was your snapshot. You can do a static report of it, but also you can create an online report of it, and the surveys list is selectable too. So even if you add more surveys a year from today, you can easily like we will show the customer first of all the timestamps of the survey, stuff like that, so it's undisputed like when the surveys were made. And then you can select which he will also see the or she will also see the kind of which surveys were selected for this report and stuff like that. So there will be no question when it was done, what was done, what areas were surveyed. And
Okay.
then the engineer creating the report has the power to check and uncheck, the options just like before.
Okay. And I noticed since you're using the mobile device, is it possible to take a picture of anything? Like let's say I found a bad installation. Can I take a photo of it and put it in as a note on that validation survey?
Absolutely, absolutely. And picture notes has been something that we've been asked for, even for the planner already. And we've always said like it will come with a mobile, and yeah, so it will have kind of text notes, which you can of course with an iPhone or iPad you can also dictate, like
Yeah.
voice can dictate your notes, and then photo notes as well.
Okay. Cool. I thought it was a pretty nice solution. I like the form factor of the actual validation device. I like how quick it actually is. Doesn't look clunky to use. It's even with the existing surveys that you did do. There's a lot of different data points, and the map actively moves without having to recalculate everything, and you don't have to sit there. And even it uploading it back to the cloud, you just like opened your browser and was able to view it. Those are all really cool features, and I think that's useful for us as we. I don't know. I feel like I always have to do surveys quickly, and I think without having any issues, this is a great way to do it. Especially when you're on site and you're like, "Okay, I gotta go. I can't sit here and wait for it to upload." It's been uploading maybe in the background, but so
Yep,
far it looks
yep,
good.
yep.
I like it.
Thanks, man. Thanks. And yeah, we really put a lot of emphasis in the fact that you wouldn't like be caught with your pants down after surveying, so to speak. So
Yeah,
let's
yeah. I've
hope
had
that
my fair share of those. Yes.
same here, same here. It happens to the best of us, of course. Uh, and yeah, if people want to know more, I mean, here we are, hamina.com. At the top, there's a banner that kind of, takes you to
Mhm.
the page where we have the survey hardware and the software if you want to learn more. And
Okay.
maybe we can put something like a link to our demo, like request a demo on the show notes. So if
Yep.
people want to talk to us like this, it takes you to me, or if you're lucky to, one of our 2 or 3 CWNEs, and there we go.
Yeah, I'll include some links in the show notes to kind of see, and maybe you can send me some screenshots to include in the show notes as well. And that way
Absolutely.
people can get more familiar to see what is available for validation survey. Now that Hamina started as a predictive, now you can do the validation piece as well and be able to see all that into the dashboard. So I think that's a development, and you guys have done it pretty quickly. I remember just testing it at the last WLPC in Phoenix, right? I tested it out. I remember
Mhm.
Joel teased a validation survey, and I was
Yeah.
asking, "Okay, when is it going to come out?" And you came out with it less than a year. I think WLPC is the same year actually. So we're recording this in December 2023. I saw Joel kind of teased it in February 2023. So you already have now it's available, right? Like people can purchase this and use it.
It can be purchased, and it will be shipping, this month. So
Okay,
it's
awesome.
it's not looking like Christmas will come after all. It looks like.
So Christmas gifts for Wi-Fi engineers, I guess. Hamina should be on that list, right?
Yeah, absolutely, absolutely. I was gonna like I was hearing you said Christmas gifts for my wife. I don't know what your wife. Maybe some of us have Wi-Fi engineers as wives as well.
That's
More man.
true.
Who knows?
Who knows? Yeah, it could be that gift. But UC, I want to thank you for showing us what Hamina has been working on. I think it looks exciting, and I encourage everyone to go take a look at it. But if you do have any questions, feel free to leave a comment down below on the YouTube video or even on the show notes, and or hit us up on Twitter. But we look forward to hearing what you guys think.
Exactly right. Thank you, Rowell. I really appreciate you
Yeah,
having me on, and
yeah.
yeah,
Thanks
glad to
for
see life is treating you well in San Diego.
yeah. Thanks for joining me. Bye,
Cheers.
guys.